Okay, packets and frames. Let's see what is this about. We will not watch the YouTube video, but we'll go from here. What are packets and frames? Well, you can see it over here, but let's read the theory. Packets and frames are small pieces of data that, when forming together, make a larger piece of information or a message. However, there are two different things in the OSI model. A frame is at layer 2, the data link layer, meaning there is no such information as IP addresses. Think of this as putting an envelope within an envelope and sending it away. The first envelope will be the packet that you email, but once it is open, the envelope within still exists and contains data. This is a frame. This process is called encapsulation, which we discussed in room number 3. At this stage, it's safe to assume that when we are talking about anything IP addresses, we are talking about packets. When the encapsulating information is stripped away, we're talking about frames. Packets are an efficient way of communicating data across network devices, such as those explained in task 1. Because this data is exchanged in small pieces, there is less chance of bottlenecking occurring across a network than large messages being sent at once. For example, when loading an image from a website, this image is not sent to your computer as a whole, but rather small pieces where it is reconstructed on your computer. There, the image below is an illustration of this process. Take the image below as an illustration of this process. The cat's picture is divided into 3 packets where it is reconstructed when it reaches the computer to form the final image. So from our computer, we make the request to the web server, and the web server sends our packets one by one until it reaches our final request. Packets have different structures that are dependent upon the type of packet that is being sent. As we'll come on to discuss, networking is full of standards and protocols that act as a set of rules for how the packet is handled on a device. With the internet predicted to have approximately 50 billion devices connected by the end of 2020, things quickly get out of hand if there is no standardization. Any standardization that you see, networking is full of standards and protocols. Any kind of standard is basically created by humans, by us. It's like math to make things easier. Like we know that in math there are theorems and formulas that, let's say, are set in stone to do something, to create a result, to manipulate some numbers to create a result. Those are standards and protocols. Standards and protocols are basically decisions or pre-made decisions or pre-made settings, let's say, for the lack of a better word, that are created to do something, right? They are created to have a better way of doing things, to have a shortcut, to have in terms of protocols, to have specific directions to take and stuff like that. So what I'm trying to say, standards and protocols are created not to be a confusion in the way. Everything makes sense when you have a standard and protocols. Let's continue with our example of the internet protocol. A packet using this protocol will have a set of headers that contain additional pieces of information to the data that is being sent across a network. Some notable headers include time to leave, checksum, source address, and destination address. Time to leave. This field sets an expiry timer for the packet to not clog up your network if it never manages to reach a host or escape. Checksum. This field provides integrity checking for protocols such as TCP/IP. If any data is changed, this value will be different from what was expected and therefore corrupt. Source address, the IP address of the device that the packet is being sent from, so that the data knows where to return to. Destination address, the device's IP address the packet is being sent to, so that data knows where to travel next. What is the name for a piece of data when it does have IP address information? Packet. Let me see, piece of packet. What is the name for a piece of data when it does not have IP addressing information? Frame. Frame layer 2, data link, packet, layer 3, network.